The research project LASH FIRE, funded by the EU, is investigating the cost-effectiveness of safety measures across the entire fire protection chain on Ro-Ro ships. These partners aim to develop and demonstrate 20 innovative solutions for fire prevention and efficient fire management. The LASH FIRE Consortium is determined to enhance fire safety at sea through proposals on how to improve onboard safety and how to update existing regulations. Together, we can make life at sea safer.
In LASH FIRE, we are developing 20 solutions that aim to increase fire safety on board Ro-Ro ships. The various solutions will be tested on board for all types of Ro-Ro ships and all types of Ro-Ro spaces. There are 3 types of Ro-Ro spaces: closed Ro-Ro spaces, open Ro-Ro spaces and weather decks. Open Ro-Ro spaces are provided with adequate natural ventilation, effective over the entire length through permanent openings distributed in the side plating or deckhead or from above, having at least 10% of the total area of the space sides. Weather deck, in contrast, is a deck which is completely exposed to the weather from above and from at least 2 sides. Also, Ro-Ro spaces fully open above and with full openings in both ends may be treated as a weather deck. For practical purposes, drencher fire extinguishing systems cannot be fitted on weather decks due to the absence of deckhead. This criterion is often used for a practical definition of weather decks. So what happens if a fire starts in one of these spaces? The sequence of events will differ depending on where the fire starts. Imagine a fire on the weather deck versus a fire in an open Ro-Ro space. In contrast to open Ro-Ro spaces, for example, there is no fixed detection system and no requirements for fixed firefighting systems on weather decks. In other words, how crew members react, how fast they do it, and the type of response will differ depending on the fire's location. These differences have to be accounted for. In LASH FIRE, we are trying to understand these activities and processes that transpire when a fire starts in a Ro-Ro space, whether it is on weather deck, in closed Ro-Ro space or in an open Ro-Ro space. If we understand the activities and processes, we can also understand what can go wrong. And if we understand what can go wrong, we will hopefully be able to do something about it. The problem is, fleet is diverse, which means that processes and activities on board during fire are not the same for all ships. Examples of factors that influence fire management on board ships are, for example, the number of passengers, the type of cargo, the number of crew members, and varying regulations. Vehicle carriers face different challenges than RoPax ships and have different resources to deal with a fire. 3 ships were selected to represent the Ro-Ro world fleet: Ro-Ro passenger ship, Ro-Ro cargo ship, and vehicle carrier. Each ship type is represented by a reference ship. The selection was based on parameters as the arrangement of Ro-Ro cargo spaces, followed by passenger and cargo capacity and statistical data of the world fleet. Stena Flavia was selected to represent a Ro-Ro passenger ship. Stena Flavia is a common and popular design of a RoPax of a size of approx 27 GT. Flavia was designed with a capacity of 880 persons on board and a total cargo capacity of 2,200 lane meters, located in closed Ro-Ro spaces, open Ro-Ro spaces and weather decks. Passenger cabins are located in the superstructure on deck 6, above the restaurant on deck 5. The remaining part of deck 5 consists of a weather deck for cars, used mostly in the summer season. Below, on deck 4, is located an open Ro-Ro space with a small weather deck in the aft. Deck 3 is the main deck, with Ro-Ro lanes throughout the full length of the ship. A small deck for about 82 cars is located on deck 2, but the deck is seldom used. Trailer and trucks can also be situated in the lower hold on deck 1. The total Ro-Ro area is about 9,500 square meters. Half of the spaces on the Flavia are closed row spaces, the lower hold, main deck and car deck. A third of them are open row spaces and only 5% are weather decks. Magnolia Seaways was selected to represent a Rover cargo ship. The total cargo capacity of the ship is 3,800 lane meters, located in closed row spaces, open row spaces and weather decks in the aft and forward of the superstructure. The vessel can accommodate a total of 18 passengers. The passenger cabins and public spaces are located in the superstructure on deck 5, above the garage. Crew accommodation is arranged both on deck 5 and deck 6. The Torrens was selected to represent the vehicle carrier suitable to carry passenger cars, vans, buses and containers loaded on trailers and trucks, with a total cargo capacity of 6,500 cars. The cargo area of 55,000 square meters is distributed in closed row spaces on 12 decks. A set of internal fixed ramps and watertight doors are provided, giving access to fixed and hoistable decks within the holds. A low-pressure, total flooding carbon dioxide fire extinguishment system has been provided for the protection of the cargo holds, where the cargo spaces of the ships are divided by 4 gas-tight divisions. By mapping out what happens on board these ships during a fire in a row space, we hope to come up with solutions that are relevant to the needs of the crew members on board the different ships. To estimate risks and to evaluate risk mitigative actions, for instance an improved fire detector, a risk model has been developed. The risk model makes it possible to estimate fire risks on the different row ships that have already been described. The risk model is based on event and fault tree analysis. These are academic tools that can be used to estimate a risk. While event trees describe the evolution of an event, fault trees are used to describe how different faults interact and lead to a dangerous situation. The fire frequencies have been possible to quantify with data from historical events. Therefore, we will not ask you to quantify how often fires occur on board the different ships. Instead, expert judgments will mainly focus on processes and activities addressing detection, first response, decision-making on the bridge, extinguishment, fire containment, and evacuation. Let me give you one example for an event tree. Fire starts in one of the row spaces. Fire detection system detects fire with a delay, during which the fire grows significantly in size. It is therefore not possible to safely approach the fire to carry out first response. Following delayed detection, the fire alarm arrives on the bridge and a decision is made to deploy a runner to manually confirm the fire. The runner confirms the existence of the fire and its location. The decision is made to activate drencher and fire is successfully extinguished. Only if the fire is not successfully extinguished, fire containment will come into play, and only if containment fails, evacuation will come into play. And here is an example for a fault tree. Only if both the crew and also the fire detection system fail to detect the fire early, then this is leading to delayed fire detection. Your task is to estimate how often certain activities, processes or systems are delayed or fail during a fire in a row space. Keep in mind that most questions concern areas that lack historical data. This means that it is not possible to rely on evidence to answer the questions. Rather, you are expected to answer with your gut instinct. While this can seem strange, it has been shown through various experiments that the aggregate of multiple gut instinct guesses can provide a good estimate of the actual value. The webinar for experts that will take place on the 8th of June will explain the objectives and provide a background to you as experts about probabilities, estimation, biases, and inform on the next steps.